Hello, this is a guide on how to set up the feathers and fur shader for your avatar in VRChat. This video is going to be broken up into a few sections. How to use textures from an existing material with the shader, how to use pre-made coat textures if you aren't going to paint your own, how to use the baking tools to pre-bake some extra data that the shader is going to need, as well as some tips and tricks on how to get the best performance out of the shader. So first, how to use textures from an existing material with the fur shader. In this example, I'm using textures made for Unity's standard PBR shader, but it's going to be a pretty similar process for other shaders as well. The package comes with some template materials, so you're just going to make a copy of whatever template you want to use, rename it to whatever you want, and put it on your avatar. Now, for the color and the normal maps, it's going to be very straightforward. For the color map, you just want to go down to this color tab and drag it into the coat and undercoat field. Similarly, for the normals, we're going to want to go down to this normals, fur tangents, and an isotropy field. And we're going to want to drag normal map into this undercoat normal map field right here. Now, for metallic smoothness, this is going to be a little bit more involved. We're actually going to want to make a copy of this texture we can edit because the feathers and fur shader actually expects this texture to be in a slightly different format than the default Unity one does. The default Unity PBR material expects metalness in red and smoothness in alpha. We're actually still going to have metalness in red, but the fur shader is going to want smoothness to be in the green channel instead. So what we're going to do is we're going to use this little swizzle function thing that's built into Unity to just move the alpha value into the green channel. Blue is used for iridescent thickness, which is not something we're going to be using for this example. It's kind of an advanced feature, so it's okay to just set it to 0. And then alpha is going to be our AO value. This example material doesn't have an AO texture, but if you do have one and it's a separate texture, you're going to actually need to open this up in some sort of image editing software and then pack that in manually. You can't just use this sort of built-in Unity reformatting thing, unfortunately. Same if you have some other material you're using, like Poyomi, where all these textures are separate instead of being packed into channels of one texture. In that case, you're also going to have to just open up some sort of image editing software and pack those all in yourself. Now we can just go to the Material Parameters tab right here and drag this texture into the coat and undercoat material parameters. So there's a couple more things we need to do at this point. First, by default, metalness just always gets set to 0. So in order to re-enable it, we actually have to set this max value back to 1 here. And then one other difference between the Unity material and this one is that Unity uses smoothness, while this material expects roughness. So in order to correct for that, we're just going to go here and set the minimum roughness to 1 and the maximum to 0. This will invert the smoothness value in the texture, which essentially converts it into roughness. You can also do this conversion in the texture itself if you want, again in some image editing software. But if you do that, just be careful to do a linear invert and not a gamma encoded invert, because otherwise the values actually might not end up being the same. But there we go. Now we have a feathers and fur material that looks basically the same as the standard material that we started with. Now at this point, if you bought the coat painting tool, you can just select your renderer and then click this button here to start painting fur cards onto your avatar. But let's say you bought the free version, or you just have a pre-made set of coat textures that you want to use instead. In that case, I'm going to show you how you want to put those on your avatar. So it's a very straightforward process. You should just have 2 of these textures, a coat parameters texture, which is going to tell the material which areas should have fur cards, how big those cards should be, and which textures from the texture atlas those cards should be using, as well as a coat direction texture, which is essentially similar to a normal map, except instead of the direction of the surface, it's going to tell the material which direction those fur cards should be pointing. So all you have to do is just drag both of these into their corresponding slots in this fur cards coat tab, and ta-da! Your avatar now has fur on it. Now, there's one more thing you're going to have to do, which is to scroll down to this normals, fur tangents, and anisotropy tab, and under the undercoat fur tangents texture field, you're just going to click this Set to Coat Direction Texture button. And what that is going to do is essentially make sure that the lighting of this underlying mesh matches the lighting for the fur cards, so that when you're looking at it at angles like this, we're able to see a mesh underneath the cards. There's no weird lighting mismatch that would, look bad. If you're using the painting tool, this gets done for you automatically the first time you start painting, but anytime you manually drag a texture into this coat directions field, you're also just going to have to scroll down here and hit that button again. Now, once you're happy with how the material looks, there's a couple more things we need to do before it's ready to upload to VRChat. As these warnings here will tell you, we have to bake an optimization texture, which is essentially something that will help improve performance, as well as baking some additional data about the mesh, and that's going to fix some artifacts that happen when the mesh is resized or animated. So first, the optimization texture. To bake it, just click here to open the tool, and then click this Generate Optimization Texture button. This texture is going to contain some process data from the coat parameters texture that's essentially going to help the shader avoid doing unnecessary work. The upshot is basically that the material with this texture will run a lot faster with no visual difference. So to use that in your material, just save it anywhere inside your Unity Assets folder, and then click this Apply Texture to Material button. The texture will get put right here on the material, and as you can see, there's also a button here to reopen the Baker tool if you need to bake it again. Something important to know is because this is generated from the coat parameters texture, anytime you change that texture, you're going to have to rebake your optimization texture. If you use an optimization texture that doesn't match the coat parameters texture, you're going to get issues with the fur cards not really rendering where they should sometimes. For that reason, you should probably hold off on baking this until you're actually done editing the fur cards if you're going to be painting them. But like I said, it can be a big performance boost for no visual difference, so you should always, always, always bake it before uploading your avatar. Now, we're also going to have to bake out some extra data into the mesh. To see why this is necessary, if I scale down the model, you can see that the fur cards don't actually scale with it. There just becomes less of them. This is essentially a quirk due to the way that Unity renders skin meshes, and it will also happen while the character animates. For instance, if the character's knee bends, the triangles on the front of the knee would stretch out and become bigger, and that would cause new cards to just suddenly appear from nowhere. In order to fix this, we're going to have to put some extra information about the mesh's starting position and scale into an extra UV slot on the mesh. To do this, just hit this button to open the Mesh Baker. You're going to see that there's an error saying that the mesh isn't readable. To fix this, we just want to select the mesh asset, and then come in and check this Read Write box and hit Apply. Now that the mesh's data is actually readable by the tool, we are just going to want to hit this Generate Mesh with Baked Data button. We can choose which UV slot the data will actually get put into right here. Generally speaking, most models are only going to be ever using data in the first and maybe the second UV slot, depending on how the model is set up. If you want to check which UV slots are currently getting used, you can select the mesh right here and then look in the corner here to see which UV channels are active. Generally, anything from UV3 to UV8 is not going to be getting used unless you've used another shader that required a similar sort of bake. So now that we have a mesh with that UV data baked in, we can just save it anywhere inside our Unity Assets folder, then apply the mesh to the render by hitting this button, and finally we can hit this Update Materials UV slot right here to actually tell the material where to look for that mesh data. And as you can see, everything looks exactly the same, except now if we rescale the mesh, you can see that the cards actually scale up and down with it. And also, after you do this, be sure to save your scene. Otherwise, the fact that you replaced the old mesh with the new one with the bake data won't actually get saved once you exit the game. If you're curious, you can find the setting for which UV channel the shader should be checking for the bake data in right here under the Skin Mesh tab, as well as, again, a button to reopen the baker whenever you want. A couple of other things to note. The first, if you set this to any UV that isn't actually, set and containing bake data, you can see that the cards kind of glitch out and don't render correctly. Also, all of the size settings for the cards that you can see here are going to be relative to the size of your avatar when you bake it. So if your avatar is very large or very small, I would actually recommend rescaling it to a more normal size for the bake and then scaling it back afterwards. That way, all these settings right here will be in more usable ranges for you than if you just tried to bake it at kind of extreme sizes that you were using. At this point, the material is ready to be uploaded to VRChat, so I'm just going to use the rest of this video to give some tips about optimization and how to make sure your avatar performs well. One of the biggest factors for performance is going to be the number of cards getting generated, and that's going to be determined by how big the cards are, since the smaller the cards, the more of them you're going to need to be able to cover an area. As you can see, as the card size shrinks, the number of cards being generated actually increases exponentially. Once you're at the smallest setting here, these cards are only about 1 millimeter apart. So as you can imagine, there's quite a few of them, and you should generally try to avoid using settings these small unless you absolutely have to. There may be situations where you do need to, like maybe you really need that fine detail like around the eyelids of your avatar or around their fingers or something. If you do, be sure to only actually paint in sizes that small in the areas that actually really need them. And also, again, be sure to bake an optimization texture, since if you don't, you will actually end up paying a lot of the cost of generating cards if that density, even in areas where you're not actually using them. That's basically what the optimization texture does. It essentially gives the shader some extra information so it doesn't have to try to render more cards than it actually needs in an area. The other big factor for performance is overdraw. If we zoom in here, you can see there are areas where multiple cards are going to be overlapping each other. And whenever you have geometry rendering over itself like this, you can potentially be paying the cost to render every layer of pixels, even if they actually end up being covered up by something else in the end. So obviously, we want to reduce overdraw as much as possible, while still making sure the fur looks good. So for this problem, it doesn't actually matter what the card size setting is, because this controls both the scale of the cards and how far spaced apart they are. And those things are in proportion to each other. So if we make the size smaller or bigger, it doesn't actually affect the amount that they're overlapping each other overall. Instead, what determines the amount of overdraw is these shape, length, and width settings. You can see if I crank these settings up, they make the card larger relative to its scale. And at higher settings, you're now seeing that there is much more overdraw. We're really only seeing the tips of these cards, and then everything else is being covered up by multiple layers here. So for good performance, you want these shape, length, and width settings to essentially be as small as possible, while still being large enough that they cover up the underlying mesh so that, you know, it looks good. So probably what you want to do to find good settings is basically figure out a ratio of length to width that you think looks good. Like here, maybe I think this 2-to-1 ratio, 12-to-6. I think with this texture, that sort of card shape looks good. But I don't want there to be quite so much overlap, so instead I'm just going to drop both of these values down in proportion to each other. Like maybe I'll try 6:3, and that looks a bit better. Maybe not quite small enough, so maybe we'll try like 3 and 1.5. Now, that obviously has a lot less overlap, but I can still find these areas now where we can actually see the underlying mesh like coming through underneath, because it's a bit too patchy. So maybe I'll jump up instead to 4-to-2. And now that kind of hits a good medium where we don't have too much overdraw, but the coat is still full. We aren't getting any gaps into it. And this also actually, in my opinion, kind of ends up looking better than the example of 4-2. You can actually sort of see more of the structure of the fur rather than it just kind of being polygon soup where we can only really see the very tips of the textures. So now at this point, say you shrunk down the size of your cards, but you actually wanted them to be bigger. Well, now instead of making them bigger by increasing these settings, you can just make them bigger by increasing the size itself instead, and that will actually make performance better instead of worse. And also, of course, if you only want the cards to be bigger in certain areas, then you can use the combing tool to paint that size in. One other thing I want to mention is that the shader also has a built-in LOD system. The way this works is that as you move further away from your avatar, it will hide cards that become too small on screen and then grow the cards around them to fill in any gaps that creates. The only settings you really need to worry about for this are these first two ones here. The first one, LOD factor, controls how big cards get before they start being hidden. You're going to want to set this basically as high as you can get away with before it becomes too noticeable. Setting this to 0 will completely disable LODing, which I would definitely not recommend. Generally, as long as you're doing like 1.5 to 2, it's probably going to be good enough in practice. The other important setting is card growth factor. What this does is this controls how much the remaining cards that didn't get lotted out are going to grow to, again, fill in any gaps that the LOD creates. The exact value you need is going to depend on the texture and the size of the cards you're using, but somewhere between 1 and 2 would generally look good. Too high, and as you move away, your avatar can start looking a little bit puffy because the cards will just grow too much, which ends up looking a bit silly. So for this, basically just move your camera a decent distance away and then just set it to some point where you can't really see any patchiness, but your avatar also doesn't look too bloated. Find that happy medium, which for this seems to be about 1.5, and then that will get you the ideal amount of lotting without compromising the visuals. And that's really all you need to know to use the shader. Obviously, there are a lot of other settings on this material that I just kind of glossed over. Most of these are more advanced features that are more intended for the power users who really just want to tweak everything to get it exactly the way they want it to be. The average user probably isn't going to have to worry about most of these, but there will be additional text documentation explaining exactly what all these settings do. In addition to that, there will also be more tutorial videos explaining how to use the painting tool, as well as the clothing mask texture generator here. But for now, that's all for this video, and I hope you found it informative and have fun using the shader.